Heat transfer, the three ways energy moves. Thermal energy is the total kinetic energy of particles in a substance. In a hot object, particles jiggle and zip around more quickly. In a cooler object, particles move more slowly. Heat transfer is how thermal energy moves from one place to another. In this video, we will explain conduction, convection, and radiation, and see how they appear in everyday life. Our goal is simple. Understand how thermal energy moves. From fast to slow, hot to cold, energy flows until temperatures balance. Let us start with conduction, the hand-to-hand transfer, then convection, riding currents, and finally radiation, energy in waves. Conduction is energy transfer through direct contact between particles. In the hot block, atoms vibrate vigorously. In the cool block, atoms vibrate more slowly. At the boundary, faster atoms bump into slower neighbors and pass on energy. Notice the matter itself does not travel far, only energy is transferred. This hand-to-hand transfer continues until temperatures even out. Metals conduct well because their electrons move freely and share energy quickly. Place a metal spoon into a hot cup of coffee. Over time, the handle warms as energy travels along the spoon. Heat moves from the hot end toward the cooler end by conduction. Conduction, energy transfer through contact. Wood heats much more slowly because it is a poor conductor, an insulator. The temperature gradient drives energy flow from hot to cold. At the microscopic level, lattice vibrations and mobile electrons carry energy. Heat then disperses to the surrounding air and to your hand on contact. That warmth you feel is conduction into your skin. Key ideas: direct contact, no bulk motion of matter, faster in good conductors, slower in insulators. Material matters: metals conduct quickly, fabrics and foams conduct slowly. The bigger the temperature difference, the stronger the flow at first. Next, when the material itself moves, we call it convection. Let us see how currents carry heat in fluids. Conduction moves energy through contact, atom by atom. Convection is heat transfer through the movement of fluids, liquids or gases. Near the heat source, fluid warms, becomes less dense and rises. Cooler, denser fluid sinks to take its place. Together, these motions create a convection current or cell. Hot rises, cool sinks, over and over, carrying energy along. In boiling water, you can see convection at work. Water near the bottom heats, rises, cools at the top, and sinks. This circulation distributes heat throughout the pot. Convection, heat transfer through the movement of fluids. Air does this too. Warm air from a radiator rises. Cooler air moves in to replace it, setting up a loop. By a cold window, chilled air sinks, creating a gentle current. Natural convection is driven by buoyancy. Forced convection uses fans or pumps. Blowing air across a surface carries heat away faster. On coasts, day-night heating differences create breezes by convection. Density changes drive motion. Warm fluid expands and rises. Cool fluid contracts and sinks. These loops move energy through the fluid volume. But heat can also travel without any material moving at all. That is radiation, energy carried by electromagnetic waves. Convection rides the current moving heat through fluids. Radiation is heat transfer via electromagnetic waves. It needs no medium. Energy crosses empty space from the sun to Earth. Some wavelengths are absorbed or reflected, others reach the surface and warm it. When these waves are absorbed, thermal energy increases. Hold your hands near a fire. You feel warmth directly from radiation. Glowing objects emit more radiation as they get hotter. Radiation, heat transfer via electromagnetic waves. Dark, matte surfaces absorb and emit well. Shiny surfaces reflect more. Absorption raises temperature. Reflection limits heating. At night, objects radiate energy to the sky and cool down. Key ideas: no medium required, energy carried by waves, surface properties matter. Now, let us compare all three and see how designs use them. Radiation sends energy in waves, even through space. 3 methods. 1 goal: moving thermal energy. Conduction: direct contact between particles. Convection: energy carried by moving fluids. Radiation: electromagnetic waves traveling through space. In real life, they often act together. Consider a thermos bottle designed to keep drinks hot or cold. A vacuum or air gap reduces conduction and stops convection. A shiny inner layer reflects thermal radiation back inside. Insulated walls do the same. Fibers slow conduction and air movement. Foil barriers reflect radiation, while cavities limit convection. Conduction is contact, convection is current, radiation is waves. Look around. These modes shape how we heat, cool, and design. Thanks for watching. Subscribe for more physics made simple.